She did this yesterday, Mrs. Westberg, and the kids came in, and I heard them, and they go, "Oh my gosh, we could use our calculator," and so it's been a while. Okay, so I showed you should, if you're absent, you should go to the calendar and watch these two videos here. We watched the first one, deriving the law of signs, just as sometimes these formulas just come out of nowhere. Where did this come from? Kind of thing. Right, and then something very specific. This is kind of an overall for section 1, 2, and 3. So it's actually what's called dealing with oblique triangles, which are not right triangles. So the problem is, even though you saw SOHCAHTOA in the video, it's because they dropped a perpendicular down or an altitude and created two right triangles out of a non-right triangle. But when you don't have a right triangle, there is no SOHCAHTOA allowed. Very simple. Ugh, I'm writing terrible. That's not the computer. That's me. It's very simple. If you don't have a right triangle, now that's the computer that drives me nuts. You don't have a what? Starts with an H. 3, 2, 1, go. Hypotenuse. So how could you use SOHCAHTOA in that case? So you need something different. So law of signs is nice, but the problem is it's not perfect. The law of signs can be used when one side and two angles are given. Good. And I'll show you that today. This is today's notes. And I feel like you've never seen this before, except if you were in, sorry, Math 3 Honors. Again, we were just talking about you out there, the discrepancies of our math classes and what this has done with certain things here. I'm going to write a naughty word down here. Two sides and one angle. That could be not like S. This is like, you know what this is? I should put these up here. This is like AAS is given or ASA, which are things that you remember from maybe proving triangles are congruent or similar, all this other stuff. That's what that first one is, if those are given. But in this one, I always like writing it like this because A, I'm a little bit off as a person, but B, that's a naughty word, and a naughty word should be a siren that this is a problem. All right, this actually creates a big conundrum. This is tomorrow's notes. When ASS is given, you could have 0 triangles, 1 triangle, or 2 unique triangles from the same information. So this is a big siren. Bad word on purpose, not to be like, that kind of guy that I am. Bad word means special condition. So ultimately, when it comes to our first quiz, which we will have a quiz on the, hopefully 7-1 to 7-3. It looks like Mrs. Westberg titled it different. But when you're given ASS, you better check for something. But we'll hold that off for tomorrow. I want to remind you of things today. Now, you will find out when you're given SAS, the law of signs does not work. So then I need the law of cosines. And at the end of our notes, I'm going to show you why, at least why the law of signs doesn't work when SAS is given. And then SSS, same thing. You will find out at the end of this why the law of signs does not work. So you'll need a different law. That's where the law of cosines comes in. I'm like, my brain's missing letters here and there. Should be a very doable chapter. Actually, the law of cosines is very easy to memorize. So our actually first quiz should be very doable. Unfortunately, there is one thing that's coming back, which is bearings, and it's coming back today. Remember bearings, 2 ships, boing, and then the bearing that they leave port at. So we got to remind ourselves of those 2 different bearing situations going forward. If you want to draw that triangle that the guy in the other video said too, you also have to mark angles and opposite sides of the same letter, lowercase. Lowercase is usually sides, uppercase is angles. I know this is side BC, but it's actually side A. All right. I find myself, actually, I do use this one more than the other one. I put the angles on top most of the time when I show my work. So that's what I think he showed on the video as well. Okay? Really hard to screw that formula up. And you only use 2 of the 3. Okay, so I threw this down just as a reminder, and then you can play along in your calculator. what we have to type on this. But you'd be silly fool if you didn't draw, and all my triangles all look exactly the same. So I make it look like a pumpkin eye no matter what. And then angle A is 32 degrees, so I stick that in there. Angle B, I guess I'll put over here. You can put it at top. It does. There's no rules behind this. And really, it's just up to you to listen. I really think this is an opportunity to raise some grades. But again, it's the choices we make. Um, and then side A is 42.9. I really went through the homework and I tried to limit it to the important ones. So I got it down to 10 questions today, as opposed to some just random 1 through 41 every other odd and all this other stuff. So I really tried to make a doable 10-question homework assignment, and we'll see where that goes. We can keep up with that daily and really knock this out of the park here. Okay, then I'll change colors. Red is given. Let's go green for what we find next. Well, I don't need work for this, but how do we find that missing angle? 3 angles in a triangle add up to what? 3, 2, 1, go. 180. So that's Mickey Mouse stuff. So could someone do that on the calculator for me real quick? I guess I should have the calculator out just to, I don't know, pretend we don't know how to work a calculator. We haven't used the calculator a while in Trig, though, so some people forget these things. And unfortunately, in Math 2 and Math 3, Trig is really ignored. One of those problematic things. I hit the wrong thing. I did. Sitting there waiting for the calculator to open, and I hit the wrong program. Well, that's embarrassing. To wait forever for this calculator to open. What was C, though? I don't need the calculator for that. So what's angle C? What's that? 66.2 degrees. I don't need to see work for that. As a matter of fact, I'll tell you what I need to see work for. All I need is the setup. So let's go to letter B, side B. It could have been letter C. It doesn't really matter. For B, I would need this written. Again, when we get to globally a quiz, this is the work shown. And then over B, so we'll put B over here, and that equals, just to get more difficult, we're going to get to, we're not going to do a whole bunch of examples of law of science. We're going to get to reminding you about bearings. And then I have to use what's given, and that's why this works. You'll find out when law of sines doesn't work. Let's talk about when it does work. How many unknowns do you see right now? How many unknowns? 3, 2, 1, go. No, how many unknowns? 1. When you have one unknown, you can solve for that. We're talking about this equation right here. When we talk about side, 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 and side angle side, the law of sines has 2 unknowns. So if you try it during a quiz, a race, and try something else, right? But we'll see that at the end. Then I guess I have to kind of cover this, because we have different levels here of knowing our basics. This is a cross multiply, and this is a cross multiply, and then this is a divide. But I will tell you, I don't need to see any of this work. I will highlight what I need to see on your paper. If I don't see this on a paper, you're a charlatan. And you may be copying or whatever and just getting your answers from your friends, or I gave you all odds and then I gave you 2 evens on the calendar. I wrote the answers down so you could check out that answer. I even thought ahead there as I was looking into teacher edition. I figured, it's about their work and doing the drawing. I'll give them the answer there. And then that's what you type on your calculator. So 42, wait a minute. Mode, am I set up? Yes or no? Am I in the right mode? Yes or no? Am I in the right mode? Yes or no? 3, 2, 1, go. Yes, it's in degrees. You got to make sure you are, though. It's not about me. It's about you. So I am in the right mode. Oop, I almost deleted that. So where am I going? Second quit. Okay. So 42.9. This is always so annoying to do this with 42.9 sine 81.8. 42.9. I shouldn't have to type the sine. Oh, and I missed the button. This is going so great. What do you do a sine? Shouldn't have to do this. What was the angle measure? 80 what? 80 what? 80 what? 81 point. This is ridiculous. What? 81 point what? 8. And then I just press enter. This is actually a smart thing to do because if the denominator is more complicated or whatever, we don't want to make a mistake. Or not, that's not really true. Some people don't close that parenthesis and hit divide. You're gone. That's where you get bad answers. And then divided by what? What did I have written there? I got it. Sine 32. I'm going to sit up here like a buffoon waiting for an answer. Sine 32. Enter. Okay, there it is, 80.12. And that's what side B is. What did I say, 80.2? 80.12. So if we just went one, was there any labels given? There were centimeters. So CMs. Okay, so work. This is all I would need to see. Bang. I don't need to see your cross multiply work and your ability to type on a calculator. Yellow is all I need to see. If I don't see that in your homework tomorrow, it's going to be typical Samuelus making his comments. You don't have to like them, but you don't say anything about it. You're not doing what you need to be doing and change your ways. See, okay, now, is this a right triangle? Yes or no? 3, 2, 1, go. No. So can I use the Pythagorean theorem now that I have two sides? Yes or no? No. So it's law of sines again, and I'm not going through the whole progression of it. I'm just going to set it up. Go back to the given. Do not use that 80.1. You may have made a mistake. So go back to sine 32 over 42.9. If you were in regular math 3, did you guys see this last year? Yes or no? You were not in regular, though, so you weren't supposed to answer. Okay, were you in regular math 3, you did not see the law of sines. Okay, that similar? Okay, sophomore year? Not trig? Yeah, see, there should be trig in math 3. We should be doing this. There also should be the coordinate plane trig, but they got rid of that. I don't think I need to do another one. I think I want to go right to the application. So it's the same old, 180 minus, set up sines twice. I shouldn't have to show this twice. Because watch what happens with this. This is really the college algebra trig. Try to draw this now. I wish I could. I can stop this. Let's see. How do I do that? Oh, I forget. I was going to try to pause the video, but try to draw this. You got the word problem right there because it's really about the drawing. And now, again, I'm trying to reach into the brains of those that remember bearings. I think I'll leave that. I don't know why I had both lights off. I guess it was because it was movie time. So really, I'm going to end the law of sines with these two bearing questions. I'm going to freeze our screen in class, and then really I'm just talking to the internet people here, and then reveal the answer. So their screen is frozen. First line should already be drawn. I actually believe this is almost a word-for-word example from our chapter 2. The problem is, in chapter 2, you always ended up with a 90-degree angle. And some of you guys cheated and knew that. Now you really got to know how to do this drawing. Really have to know how to do alternate interior angles to get the exact angle measures in the triangle created by the situation. So now there is no faking it. And that's why this has come back. So we introduced the idea in chapter 2. Now we revisit in a more realistic fashion where you don't get 90-degree angles in the real world. It's very hard to get a 90-degree angle. All right, so I did freeze this class. So the first thing we do is, the first sentence means we have a line like this. Before I draw this, though, I think about the bearings. So where is this east line, west line? Above the situation or below? So it actually is here. Because when I look at these bearings, if you remember this question, those out there kind of listening, you really should know where are these two stations. We'll call it station A and station B. And it really depends on what the bearings are. Okay, and they do have it as station A. So north 42 east. Okay, I should ask you the question, where's north 42 east? Is that above or below? 3, 2, 1, go. That should be easy. above, and then what's east? The right or left? 3, 2, 1, go. Right. Okay, east is over here, west is over there. Think of a map and think of New York and California. So north 42 east is this. I'm not showing this to you guys in class. You're supposed to be drawing your own and seeing if you can get it. And then along that line is where that fire is. Okay, and then actually my drawing is inadequate because now I just looked at the other, and you don't have a ability to do this. You might have to erase. I have to shrink this down because this has to extend pretty far because my other bearing is north 15 and then east. So that's where the fire is. That's an obtuse angle right there. Okay, so now I'm going to unfreeze. This is the initial drawing you should have got. This is what I mean about every drawing looking about the same. Okay, so number one, they're on an east-west line of each other. The bearing of the first fire from station A to the fire. See, that's why I think people mess up. Paul, you okay? Because I really don't like that stance during this. No complaining later. All right, taking a little break during the notes there. But anyway, north 42 east, it's from the station to, you go north 42 east on that line. So this is 42 degrees here, north, and then you rotate 42 degrees off the north axis in an easterly direction. So that line is literally going northeast. We should be able to get that. And then that's why I had to change my drawing. You didn't get to see that in class, but I put it on the video. I had this line like way up here, and then this is north 15 east. So this is going upper right. So I had to adjust my drawing to make that happen. All right. So that's north 15, and I'm going to make this sliver 15. So actually, you're lucky. You don't have to do any alternate interior angle stuff. Maybe I'll change the color to red. What is this full angle measure from here to here? That should be very simple. 3, 2, 1, go. 105. So it's actually the most basic of geometry that you need sometimes. Sometimes it's alternate interior angles. Sometimes it's a little bit easier. Then you have to have the ability to get rid of 15 in your head. And why do we know this is 90? Again, you put crosshairs on. The people that could not get bearings done refused to put crosshairs or compasses on each point. And that's why they could never figure out how to get these angle measures. So compass, and then 15. But I know that's 90 because it was a direct east-west line, and I know this is a vertical. So 90 plus 15, sorry. And then because this is 90, this is 48. Because this is a direct east-west line, this is directly horizontal, so that's vertical. So through 180 minus, I could get that last one. Let's try to do that mentally. 48, 53, 63, 73, is that 27? Okay, so very simple to get all the other angle measures. And then once you get all that, it's so simple to get this answer. I forgot to write one thing, though. Two rangers are an east-west line of 110 miles apart. Actually, I got to make sure I show the introduction to this chapter. It talks about GPS. It's kind of cool. Triangulation of vectors. We're going to do vectors at the end, just simple, basic on a piece of paper. Mickey Mouse. How many people are in physics or have been? Raise your hand, physics. You've done vectors, right? We're going to even do it simpler on a coordinate piece of paper, plain. Then talk about real minor physics questions, like pulling the turtle up a ramp. You got your gravity vector, you got your ramp vector, all that kind of stuff. No friction vector, going to account for no friction kind of thing, which is not really true. All right, so how far is the fire from the western? So here's the western, to the east-west line. So west is over here, so that is station A, right? How far is the fire from the western station? So this is what I'm finding X. So actually all I needed was the 105. Actually, that's a lie. I did need the 27, okay, because 27 is opposite 110. So it's law of sines, sine 27 over 110 equals sine 105 divided by X, okay? and then crisscross multiply. Really, you should be able to figure out that it's x equals 110 sine 105 all divided by sine 27. What do we get as an approximation? I hear some people pressing buttons. Anyone? 234 point. Really? So 234.0 MIs. Anyone else verify that or no? Yes, you got to shake your head. So 2 people, 3, good. Appreciate that. That is good. Okay, try this one then. I can zoom in on this one, but you have it on your own piece of paper. This is good for the video people. We'll do the same thing. I'll pause because really the math is easy. It's about getting the drawing. It's about getting this bearings taken care of. And hopefully your brain, the wrinkle in your brain about bearings comes back a little bit. I forgot to tell you the other way of doing bearing too. I probably should mention it in this one. Like what would be an equivalent bearing in north 52 west the other way? Okay, so the first thing you should think of is at the starting point, where is the lighthouse from the ship or the ship from the lighthouse, depending on how the question's worded. Everyone remember, actually, it was with Mrs. Shavanik, working with her when we first got this book. We struggled with this one as we threw it in our notes. And then we figured out we got to really focus on the word to and from. To this, from this to this. The from gets the bearing. From this to, the from gets the compass. Okay, so that's what we really struggled with. That's an honest. Boy, that was probably 2009, I think. I know how long ago it was that we started with this book. Somewhere around that. Okay, so like I said, I think I did freeze their screen. So you first have this. You look at this and understand where is that in comparison with the ship. So it's bearing the lighthouse from the ship to the lighthouse. So here's the ship. Oh boy, we're drawing ships now. That bearing is south 52 west, which is in that direction. And then there's the lighthouse. Some along those lines. I don't know, that's a lighthouse. Wow, that's awful. Okay, then this ship travels due south. We'll do that as like a little green squiggly line. Then I'll put another compass at this new part. 5.8 kilometers. And then we'll reveal it to the class. You should be testing yourself, just like you're testing yourself and the 3 people that just calculated. Can you get those same calculations? When we do nothing, don't expect. It's really the thing. Okay, 23, that makes sense. This angle should close when we draw this next thing. And that's 23. And make sure you mark your angles, and now I'll reveal it to the class. Okay, unfreeze. This is why your drawings, everyone's drawing should be in this framework. Everyone's triangle has to look like this. Your ship goes due south. I should draw my ship again. And the lighthouse should be in the upper left corner. This is where, when I get triangles that are not even close to this, there is absolutely no credit. There's none I can give you, right? And you leave me handcuffed on that when we can't get this figured out where things are in relation to each other. There's where the ship ends up after it goes due south. I don't know why I changed its look so much, but anyway. You do have one of the angles in the triangle, and then another one is actually even easier. So I feel bad. I didn't really get good examples here of having to do alternate interior angles. I think with law of cosines it might happen. Because this is a straight angle. So this obtuse angle right here would be 130, wrong, too big. 128, correct? Right, everyone? 128 degrees, correct? All right, and then that leaves 148, 151. So does that leave 29 degrees here? So it's actually the most basic of algebra you need to do in order to, basic of geometry, 180 minus and straight angles and all that other stuff. I think with law of cosines questions, we got to use the alternate interior angles. I know in section 24 or 2425, dang it. I think in bearings these come back again. You could use the idea of bearings with ships traveling on the sea, and the same exact questions come up. So I know that will happen again. So it's and then what do they want? Find the distance between the ship and the lighthouse at each location. So we'll call this location A and this location B, just for purposes of well, actually, that's not true. If we call this triangle ABC, then this would be B would be the first location's distance, and then A would be the second location's distance if I named this triangle ABC. So I kind of convoluted that a little bit. So, but what do we use as the given? Sine 29 over 5.8 because it is opposite that 5.8 miles. And that equals, for the second location, sine 128 over A, I guess. Don't worry about the letters too much. It's just, we're finding X and Y. You're going to call this X and this Y. X is the distance from the first location, Y is the second location. Probably overdoing it here. And then yet again, sine 29 over 5.8 equals sine of 23 over B, how far it is from the first location. And then we already showed you a couple times how to do this on the calculator. All right? Okay. I don't want to overdo it. All right? I think this is pretty simple. Why doesn't the law of sines work? This is going to happen to you in the first quiz if we do get the law of cosines. I have a feeling this is an illegal sheet. All right, so who's this? Who? Oh, I thought you were giving it to one of my students here. Didn't you sign in?
Well, that was when I guess when it was broken.
Huh?
That was from yesterday.
Are you sure it wasn't Friday?
Say something that was Monday or something.
What's the date today, guys? Does anyone know? Okay, this was, yeah, you were there yesterday and today. Okay. It wasn't broken yesterday, though. I got it fixed, so I don't know what happened. Okay. So this is what's going to happen to you on a test. We're going to throw the law of cosines at you Thursday, I hope. That was the plan. I'm doing what the other kooky teachers are doing. But imagine if you had 7, 8, 9. You had a side given, and you called this triangle ABC. You should see immediately why the law of sines will not work for this. Because my only choice is I have to have an angle, and angle A is opposite side 7, and then I got to use another angle. I don't know any of these angles. So what you end up getting is two unknowns no matter what two things you pick. So this is why the law of sines doesn't work for SSS. It'd be a sad choice if you pick that. And then SAS is like this, and I'm going to make up something for SAS. I don't know, 40 degrees. This is SAS, 7 and 8. Let's just say those are those lengths. We'll call this ABC again. And then know how opposite sides work. So this is side A. I only have one angle, so I can't find any of the other two angles right now. So I have to use 40 degrees. So sine of 40. And then you already should know what the problem is. I don't have any of the other angles, and I also don't have side A. So no matter what I try to find, or what I use, I have two unknowns, which is unsolvable. So for anyone to use the law of sines in these two cases, you just reverse and get to the law of sines. It should never happen, is what I'm saying. And that's what the dealio is there. Now I'm going to bore you with one more video of a nice teacher. So here we go. I guess I wish I should have stopped this video, but I guess you can watch this along. I don't know how the sound works on this.
A family vacation.
Oh, great! Now I'm advertising in class. Get in trouble.
Hey everyone. Quick area of triangle.
Oh, I'm sorry.
Same
It's an
thing that I
ugly,
showed you
mean
earlier. Sorry,
teacher.
second hour, and I couldn't get that sound figured out.
Apologize.
Third hour, thanks Matt B, right, for figuring out how I can get my sound to work on a video, how I present it. So
This is from
thanks a lot for that for sure. But when I say area of a triangle, this is why they insert this in the law of sines section, by the way.
Did you hear
The
him?
first thing you should think of immediately
You have this right
is
here.
1/2 base
Is that how you take notes?
times height.
Right? Simple. This is
Okay,
what
and taking a minute to write that. So,
this is what
all right,
math
great.
is.
So if I had all those letters and
Substitutions.
numbers, I'd be able to stick the numbers in and find the area. Well, here's why it's in the trig section. Just like the guy in the video today for deriving the law of sines,
Correct.
you can also derive an area formula. So in this question, the way this drawing is, side A is the base. So here we go. We're going to start substituting. Whatever A is as a number, it would go in that position. That's
Correct.
not a big deal, Mr. Samuelis. It's looking just like my grade school examples. Well, then we're going to do what the guy did for deriving the law of sines. Let's derive what the height is in terms of
That's exactly what he did.
trigonometry. And he did this is almost exactly what he did, but now we're going to turn this into an area formula. Now when you focus just on the blue right triangle, H is the opposite side of angle B.
Now I'm allowed to
I didn't write this yet, but this is side C all the way across angle C.
True.
But for the blue triangle, I don't know, make that blue, I guess. That's the hypotenuse.
Exactly
So
what he
that's the
did.
trick. This may help you with understanding what was done earlier today to derive the law of sines. So in terms of trigonometry, sine of B, now that I'm dealing with a right triangle and the blue thing, equals H over C. And then solving for H, because that's what I want to replace, multiply both sides by sine. So the height, maybe we'll put this in yellow for substitution, is actually whatever side C is times the sine of B. And there you go.
Let's see how much.
I want you to notice something. If you look at this overall, and I erase all this now,
Can't see how much I have
except
left.
for the two side measures C and A and angle B, this is an SAS scenario.
It is SAS.
What we're saying is if you're given SAS, you can just insert the sides and the angle in this formula, and the answer is there. That's what a formula is. Now, as the guy said about his deriving,
I should get the old Mr. Samuelson.
What if I flip the triangle over and drop the
two Samuelses? I can't handle this.
Or from B,
it's actually 3.
then these two formulas would result. 1/2 AB sine of, can anyone guess what the angle measure would be? Look at this. Side A, side C, sine
What would the angle measure be, everybody?
I really want to make SAS
1/2 AB sine
C. That is another SAS scenario. Or if I flipped it around and dropped a different height to a different base, then it would be 1/2 BC sine of anyone? A. So these are formulas that would work.
Oh, sorry. Okay, and that's it. You know what I'm going to do next year? I'm going to tape this tape, and then I'm going to have 3 Samuelses here, and I'm going to keep doing this until I end my career, and there's going to be Samuelses all over the page. I think that's a great idea, especially for those that hate me. It's like, oh my gosh, it's the worst day of my life. Sorry. So the whole point of that was you fill all that in from my old description. So now what happens? It's so simple. Look at what we have here. Oh, son of a nutcracker. I'm just going to make up some labels here. Let's say this is, what have I been using? 6 inches, 7 inches, and then 33 degrees. First of all, is that side angle side given, yes or no? If it's side angle side, then it's a plug and chug. The area of this triangle is, let's put inches. And then it's just half 6 times 7 times sine of 33. And that's all she wrote. All right, and that's all you got to do. You got to press the buttons and press enter because side angle side is given. Of course, this is cat, me, a yow. This is 88 degrees. This is 7. Oh, I got to be careful. I got to be careful because I don't want to give you an ASS scenario yet. All right. So I got to do like this and say this looks like about 24 degrees. So I will get goofballs. Oh, I have three numbers, and he asked me area, so I'm just going to stick the three numbers in the formula. Are those the three numbers that represent SAS? Yes or no? No. So what do you got to do about it? Ooh, that sounds threatening. All right. Well, you got to make SAS, and then this is why it doesn't matter. Okay. So first of all, what's that third angle that's missing? What's the third angle missing? What's the third angle missing? 112, so is that 68? Is that correct? Can someone verify that? So then what you have to do is make a choice. What side do you want to find? Top or bottom? First person. Bottom. Okay, fine. We're finding that one. We have to use the law of sines then. Humor me and actually calculate this. And okay, fine. We'll call this ABC. Sometimes it is helpful. So I'm finding side A. So I'm going to find that bottom. And then I have to use that given 68 and 7. And I will get goofballs. This is the law of sines. Won't even write sine in here. They'll write 24 over 8 equals 68 over 7. I can't help you. You have you've given yourself your own F. All right, but anyway, could someone tell me with a verification as they cross multiply and solve what is A equal to? You don't want to round this one. You want to keep the decimal. So it'd be 7 times sine 24. I really shouldn't have to show you that. Divided by sine of 68. What do we get for that? I saw you hit that. 3.07. But leave your stuff all the way out. This is 3.07. Which angle do I have to use for the area formula? Which angle do I have to use for the area formula? Is it 68, 88, or 24? It's got to be the 88. Because now when you said bottom, you've created this SAS scenario. So you must use those three numbers in the formula. It just comes from getting the right numbers in the formula from what I just derived with you. If you did the top side, if you found the top side through the law of sines, then you'd use the 24. And you'd end up getting the same answer, actually. Anyway, A equals a half. Don't round this. Take this decimal that's on your calculator all the way out. Times 7 times sine 88. Boom shakalaka. No, I went to the end, but I really don't think the homework is too bad. I made it super simple.